Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the application of vectors. Last time, we learned some of the applications of vectors to algebra and geometry. We also learned about the vector equations of lines. Today, we are going to continue our studies by learning about the relations of vectors and circles, tangents, and their practical applications. Are you ready, students? Let us begin. Observe this circle. It has a center at C. Vectors P and C are position vectors of points P and C. The radius is the set of all points P in the plane that equals the difference between the magnitudes of vectors P and C. The square of the difference between the vectors P and C is equal to the radius squared. Put another way, vector P minus vector C times the result of vector P minus vector C equals the radius squared. P times P minus 2P times C plus C times C equals the radius squared. This equation is satisfied by a position vector of any point on the circle. It represents the equation of the circle centered at C with coordinates x0 and y0 and radius r. If we substitute the corresponding components of P and C into equation 1, we obtain this: x minus x sub 0 squared plus y minus y0 squared equals r squared. This is called the standard equation of the circle. Students, please make a note of this. By expanding and rearranging the terms, the standard equation of a circle may be expressed this way, where A equals negative 2x sub 0 and B equals negative 2y sub 0 and C equals x sub 0 squared plus y sub 0 squared, then x squared plus y squared plus ax plus by plus c equals 0. Here is a new circle. It has its center at 2, 3, and a radius of 2. Try to find the equation of this circle, students. Here's a hint. Use equation number 2 to help you find your answer. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Remember the relationship that P times P minus 2P times C plus C times C equals the radius squared. Therefore, when we substitute the vector components, we may express the equation of our circle like this: xy squared minus 2 times xy times 2, 3 plus 2, 3 times 2, 3 equals 2 squared. After multiplication, this is our equation. X squared plus y squared minus 2 times the sum of 2x and 3y plus the sum of 4 and 9 equals 4. We can move the 4 over to the other side of the equation to make it equal 0. So the final equation is x squared plus y squared minus 4x minus 6y plus 9 equals 0. Does that match your answer, students? Well done. Now, let us learn about tangent lines to a circle. They are characterized by the fact that the radius at the point of tangency is perpendicular to the line, like this. This will be the equation of our circle. Here is the line tangent to the circle at point 1. Point P is an arbitrary point on the line tangent. The dot product of the vector between points P1 and C and the vector between points P1 and P is 0. Therefore, this must be the equation of the line tangent. Subtract the second set of coordinates from the first set of coordinates. Square the results, then add them together. The sum is equal to the squared radius of the circle. By adding the standard equation of a circle to both sides, we may follow these steps. Finally, we see that the sum of the product of the difference between the coordinates is equal to the squared radius of the circle. If the circle is centered at the origin, this equation is expressed as the dot product of x and x1 plus the dot product of y and y1. This is equal to the squared radius of the circle. Let us try applying these formulas to an activity, students. A tangent is expressed as x squared plus y squared equals 18, and point P1 is at 3 and negative 3. See if you can calculate the equation of this tangent. Are you ready? Please go ahead.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Did you notice the significant property about this equation? Correct. The circle is centered at the origin. This makes our calculation much simpler, does it not? The radius of the circle is the square root of 18, which is 3 radical 2. The equation of the tangent is the dot product of x and 3 plus the dot product of y and negative 3 equaling 18. Therefore, our answer must be 3x minus 3y equals 18. If that matches your answer, great work. Let us now see how well you can apply your skills to one more practical problem, students. See if you can find the equation of a circle that is centered at 2, negative 2, with radius 4. You may go ahead now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello once more. I hope you had no trouble. We can begin to solve this problem by calling point P at coordinates x and y a point on the circle. Vector P and C are the position vectors of points P and C, respectively. Therefore, the equation of our circle looks like this: x squared plus y squared minus 2 times the difference of 2x minus 2y plus 4 equals 16. The rest is simple, students. Here is our final answer. The equation of the circle is x squared plus y squared minus 4x plus 4y minus 8 equals 0. I am sure that you calculated the correct answer. Great job. That is the end of this lesson, students. Today we have learned about the standard equation of a circle and the tangent line to a circle. We have also solved practical problems using what we have studied. Until next time, thank you, teacher. Thank you, students.